So today's lecture is on loops and debugging. The loops part of it, a lot of it should be review for you, especially given a lot of the pre-work that you've already done. Loops, we're going to be covering probably the two or three most common forms of loops. And I think for me, the biggest thing here is for you to understand not just like how to use them, but really like how they really work on a very deep on a more like deep level. And the reason for that is because loops are actually incredibly powerful. The downside is we typically only see them used in certain contexts, and so because of that, folks tend to think, oh, a for loop only does this, when in reality, a for loop actually does a lot. And if you know how to customize it and how to use it, it can be a really powerful tool in your toolkit. We'll also talk a little bit about debugging, but that one's more of a soft thing. Like that will kind of be a part of all the workshops we work on over the next month. And the reason for that is just because, as a programmer, if I could make a pie chart of time that you spent when you're writing software, quite honestly, maybe like 40% of it is you reading code and trying to understand what the existing code base says. Maybe like 20% of your time is spent writing new code. And then the other 40% is spent testing and fixing and debugging code that you've already written, but it doesn't work the way that you thought it would. And that's a very common breakdown. And so debugging is going to be a major part of your life, unfortunately, whether you like it or not. It doesn't matter how good you are. Every programmer will spend way more time debugging and testing code than they spend writing it, or at least they should. So we'll cover a few slides on kind of basic debugging tactics, but that'll be more of a thing that you'll be practicing and applying over the next months throughout. So we won't have any problems just necessarily on debugging. All right, so let's get started. Okay, so loops and debugging. So the first loop we'll talk about is one that is one I think you've already seen to some degree in the pre-work. It's the while loop. So the while loop has three parts. The first one is a while keyword. The second one is a conditional expression that converts to a boolean, and so I'll explain more in depth what that means. And then the third part of it is a block of code. If we take these one at a time, what the while keyword does is we start off every while loop with the while keyword. In most code editors, in most JavaScript code editors, if you type in the word while, you'll notice that it probably writes in a different color than the rest of your code. So, the rest of your code could be blue or white, and while might show up as red or green or just some other color. And the reason for that is because while is what's considered a reserved word in JavaScript. What reserved word means is like that word means something very, very specific in JavaScript, and so you can't overwrite that with anything. So you can never have a variable called while. You can't create your own version of while. Like while is something that kind of comes built into JavaScript. So other examples of keywords that we're going to see are things like for, function, return, right? These words kind of are all part of the actual JavaScript language, and so you can't really overwrite them or use them as variable names. And so if you ever do see someone use a while keyword, know that that always means they're using a while loop. There's nothing you can customize about the word while. Yeah, cool. So that's the first part of the while loop. It's just this while keyword that denotes, hey, here's where my loop's going to start. If we look on line 6 there, we'll also see after we write the word while, we'll have a parentheses, and in the middle of it, we have a conditional. What a conditional expression that evaluates to a boolean, what that basically means is we're going to have a block of code in between, or we're going to have an expression, right, or a line of code in between those parentheses. And the short of it is, no matter what that value becomes, or no matter what that value evaluates to, we just want to know one of two things. Is it true or is it false? And it has to be either one or the other. And so when we say that evaluates to a Boolean, what we really mean is, hey, whatever's in between those parentheses, we don't really care. All we know is at the end of the day, we are going to get a Boolean value out of that. So it'll either be true and it'll either be false. And why is that important? Because for a while loop, the only thing that a while loop really cares about is it only has kind of one decision tree, if you want to think of it that way. It just needs to know, am I executing this block of code or not? Like yes or no, right? There's no like nuances there. It's just, do I do this block of code or no? And the block of code that we talk about is basically everything in between the curly braces. So the curly brace or the block of code starts as the last character on line 6 and it ends as the first character on line 8. So basically everything on line 7 is what we consider the block of code. And so the way that the while loop works is basically it will evaluate that expression in between the parentheses on line 6, and it will get back a value, and it will ask, is this value true or false? If it's true, we're gonna run that block of code on line 7. If it's false, then it means we stop and we're done and we move on to line 9, right? However, if the conditional and so how the looping part of this kind of comes into play is the first time we go through the while loop, we'll say, is the conditional true or false? If the conditional evaluates to become true, we're gonna run the code. After we run the code on line 7, we actually loop back to line 6 and we run our conditional again to check, hey, is this conditional now true or false? If it's true, we run the code again and then we do another check. And so we'll do that over and over and over again until eventually, like one day, hopefully, our conditional becomes false. And so we call it a while loop because the I guess a more English kind of association there is, while the conditional is true, we will just keep doing this over and over and over again indefinitely until the conditional eventually becomes false. So a while loop, when we write it off, we may not know when it stops. All we need to know that eventually it will definitely stop. Okay. Any questions on that kind of high level walkthrough before we take a look at an actual while loop? Everyone good? All right, cool. Okay, so let's take a look at a very simple while loop, right? On line 1, we have this variable called count. We set it equal to 3. And then on line 3, we basically have this while loop that says while, and in between these parentheses now we have our expression. The expression says is while count is greater than or equal to 1, which very basically just means, hey, is this count variable, is the value of it greater than or equal to 1? And so when we run this while loop, we get to line 3, we say, is count greater than or equal to 1? Well, count is 3, so yes, 3 is bigger than 1. And that means we actually are going to run the code block that's on lines 4 and line 5. What line 4 does is line 4 says, well, let's console log out count is, and then let's also, after we run line 4, we can also run line 5, which is let's subtract 1 from count, right? So after line 5 is done, the while loop says, okay, I ran it the first time. I don't know if I should stop yet. Let me check the conditional again. So after line 5 runs, we then go back to line 3 and we say, while count is greater than or equal to 1, well, what's the value of count now? Because we decrease count by 1 on line 5, count is now equal to 2, and so our conditional on line 3 becomes, is 2 greater than or equal to 1? And the answer is yes, 2 is greater than 1. And so then we go through the code block again. We console log out line 4, which is count is 2. We decrement count by 1, so now count is 1. And then we go back to line 3 and we keep running our while loop. Remember, a while loop will keep running until the conditional becomes false. And as of right now, our conditional has been true every single time. So we keep running this code, right? When count becomes 1, we go to line 3, we say, hey, is count greater than or equal to 1? And the answer is yes, 1 is greater than or equal to 1. So then on line 4, we run our console log one more time. We say count is 1, and then we decrement count one more time, and now count is 0. So then when our while loop goes back to line 3 and says, hey, is count greater than or equal to 1? The answer is false. It's not, right? 0 is not greater than, and 0 is not equal to 1. And so therefore, at that point, the conditional becomes false. The while loop says, oh, okay, great. Like at this point, my conditional is false, which means I'm done with the loop, and I don't need to run any future iterations. And so at that point, And so at that point, our code finishes. Any questions there? Okay, great. The while loop, just so you know, the while loop by definition, it only requires one thing, which is it needs a stopping point. If I write this while loop here, where my conditional inside my parentheses is, where my conditional expression starts off as false, that's totally valid, right? My while loop will never execute a code block, but the while loop is at least checking, and it'll check once. It will say, great, is false or true? And the answer is, well, false is false. So therefore, this while is gonna check on line 1. It will say, great, my loop is over, and it will move directly to line 4. And so even though this code block on line 2 never ever runs, this is still a very valid while loop, right? So while loop doesn't need to run X number of times. There's no guarantee that a while loop will run at least once or at least twice, but it's guaranteed that it at least needs to stop, like I guess once, but really it basically just needs to stop, period. Similarly, if we take the converse of that, we'll say, hey, let's do while true, and we do console.log out, this line will run forever. We'll notice on the right-hand side of the screen that our console log just starts printing out code and nonstop. And the reason for that is because on line 1 there, when we check for conditional, when we check whether or not true is true, well, it will always be true and it will never become false. And so this loop will actually never terminate. Realistically speaking, most computers and programs now are pretty adept at determining when you have basically we call it an infinite loop. So it'll probably cut you off at some point. In the old days, like you would just actually use up all your computer's memory with bad code, and it will stop when the computer runs out of space. But in any case, we have enough safeguards in place that this is bad code, but it won't break the computer. But this code basically is not really usable, right? Like we can't run this because when we run this, like this is never going to kind of give us what we want. And so this kind of leads to another major idea in the creation of a while loop, which is, hey, when I'm writing a while loop, my conditional, that thing on line 1, that should be getting closer and closer to false with every iteration. I may not need to know exactly when it ends, but I need to kind of assume that it will end at some point. Right. So the example I always give for this is if I think of if I create a while loop that says, hey, roll a die, right? If I get a 6, then stop. Otherwise, I'm gonna keep rolling until I get a 6. In that scenario, I don't know when I'll hit the first 6, right? It could be on the first roll, it could be on the 1000th roll. But what I know is that even when I can't tell you exactly when that loop's gonna stop, I have a good enough grasp that the loop will eventually stop. And so, so when I say, you want the condition to be getting closer and closer to false, you don't need to know exactly when that point is. You just need to say with a reasonable degree of confidence that you will reach that point. Otherwise, what you see on the screen is what happens, right? The code just runs infinitely and never stops. Any questions so far? Yep. And so this is another example of the same idea where this looks very similar to the first example we did, except here on line 4, when we do count, is when we check whether or not count is greater than or equal to 1. We on line 5, we in our code block, we console log what count is, but we never change count. And so line 4 is always going to be true, and so therefore we're always going to print out count is 3, over and over again, non-stop. And so once again, this is just kind of brings back to the idea that, hey, we want our conditional to eventually be getting closer and closer to false. Cool. So that was a while loop. Any questions on while loops? Everyone's good? All right. Okay, well, we're a third of the way through. Next one is for loop. The for loop is so while loops, they are a part of JavaScript, but quite honestly, they're not used as commonly as for loops are. And the reason for that is because, with while loops, you do want to kind of be careful that you don't set up a scenario where your code just runs infinitely or nonstop. And so because of that, people tend to kind of err on the side of caution and say, hey, let's use a loop where I explicitly set the start and stop date, or set and stop like points or junctures. And so a for loop, you'll see, kind of does a much better job at that. A for loop also requires 3 elements. The first element is the for keyword. The second thing that requires, I guess we're kind of cheating here, is actually 3 different things, but we need 3 expressions. And the third thing we need is also a block of code. So the for keyword, once again, for is a reserved word in JavaScript, so you can't override it. Whenever you see the word for in JavaScript, it has to be used in reference to creating a for loop. There's just no way around that. And then on line 4 there, or the third item, a block of code, that's just the same curly braces that we saw before, right? So items 1 and 3 are almost identical to what we saw in for the while loop. The difference here is for the second item, right, which is actually 3 things. So for a while loop, in between the parentheses next to the while, or in this case next to the for keyword, we have 1 thing. Here we have 3 things, and notice how the 3 things are separated by a semicolon. Very, very critical. If you use a colon or a comma or a period, like the code just won't run, right? It has to be a semicolon. So this is a part of JavaScript where, unfortunately, you do need to do a little bit of memorization and just know that, hey, the different parts of for loop, they are separated by a semicolon on line 6 there within the parentheses. So what a for loop does is a for loop has 3 steps. The first step is what we call initialization. The second step is a condition, and the third step is what we call the final expression. So what does it mean? Well, so the initialization, as the name indicates, it's a initializing step. And for every for loop, just please keep this in mind, the initialization will run only once. Okay, it will only run once, and it will run as the first part of the for loop. Once it runs once, it will never run again. What the condition does is very much like a while loop whose decision tree is like, hey, should I run this code block or not? Yes or no? That's what the condition is there, that in the middle there for the for loop. So the condition is our way of checking to make sure, hey, do we run this expression or do we run this code block? Yes or no, right? And so just like in a for loop, the condition here is also going to evaluate to a Boolean, yes or no. The last part is this thing called final expression. So if you notice how in the previous example, when we were doing the while loop, when we had while count is greater than or equal to 1, we were editing count within the body of the while loop code block to say, hey, let's decrement count by 1 each time we run this code, right? And it definitely works, but it's also one of those things where someone could have it in their code block, someone could not, right? And when they don't have it, it kind of leads to much bigger problems down the road. Instead, what a for loop does is the for loop says, hey, let's explicitly move that thing into the creation of the for loop. So after each run, I know exactly kind of how I'm changing the thing that I'm measuring for. So let's see how this looks in real life. Yep, so this is basically what I was saying. Okay, so if we look at this for loop here on line 9, on line 9 there, within the parentheses here, our first step is this initialization step, and it says let I equal to 1. Okay, and all that's doing is, well, so one thing, this runs first and it runs only once. Okay, so just please keep that in mind. One of the biggest mistakes I see people do when they use a for loop is that they think the initialization runs every time the loop runs, and the answer is no. It only runs once before any loop runs, and then every subsequent loop after that, it doesn't run anymore, right? So we only say let I equals 1. We only create this variable called I once, and we set it equal to 1 initially. Okay. In the middle part, the condition is I is less than or equal to 3. So basically, every time before we run our code block, we're going to do a check. Is I less than or equal to 3? Yes or no? If it's yes, we're going to run our code block. If it's false, we're going to stop this for loop and we're going to move on to the next line. So in this case, we're going to move on to line 12. Okay. If the condition is true, we then run our code block, which which is basically just line 10. So if the condition is true, we run line 10 and say console log out I is whatever it is. And after our code block finishes running, then we run the third and final part of our expression there on line 9. In this case, the expression right there is this I++, which means after we're done running the code block, we'll then edit I somehow. In this case, we increment I by 1. Right? Once we increment I by 1, the for loop is going to say, well, I ran once, should I run it again? And the way it determines that is by running the conditional again and say, great, is I less than or equal to 3? We started off with I equals 1. We checked to see if 1 is less than 3. It is. We ran our code block on line 10. And then afterwards, we ran the I++ there on line 9, right? Our final expression. So now I, which used to be 1, is now 2. And so what the for loop does now is the for loop says, great, let me check my conditional again. Remember, we're not doing the initialization anymore. Now we're just running this conditional in the middle. We're just checking if I is less than or equal to 3. In this case, is 2 less than or equal to 3? The answer is yes, it is. So let's run our code block on line 10 one more time. And then we'll run our final expression one more time as well, I++. And now I is equal to 3. The for loop will then say, great, let's see if I need to run it one more time. Is 3 less than or equal to 3? And the answer is yes, it is. And then we'll go into our code block again. We'll console log out I is 3, and then we'll run our final expression one more time. It will say I++. So I is now 4. And now what the for loop does is the for loop doesn't know to stop right now, because as far as the for loop is concerned is, hey, I haven't gotten a false yet for my conditional. And so the for loop is going to run the conditional one more time. It will say, is I less than or equal to 3? I in this case is now 4. So is 4 less than or equal to 3? And the answer is no, it's not. And so once the condition returns false, then we can confidently say, hey, we've reached the end of our for loop. Let's move on with our code to the first line after the for loop. So let's move on to lines 12, 13, and 14. And so a bit of a kind of like a very detailed walkthrough, but I think it's very important that when you see a for loop, you understand exactly kind of what the initialization does and what each step the for loop subsequently takes. Just remember, the conditional, that's right. So for each part, the initialization, the first third of it, only runs once at the very, very, very beginning of the for loop. The middle part, the conditional, that part is always going to be a true or false, and depending on whether or not it's a true or false, it determines whether or not you run your code block. And then the last third is what runs after the code block is written, and usually that piece of code is something that kind of helps your conditional move further and further along, so that eventually it will return false. Because once again, just like a while loop, a for loop could not run a single time and still be valid, but a for loop needs to have a stopping point because the code needs to know, hey, when do I stop? Any questions? Okay then. Yeah, so notice how when I was describing a for loop there, all I said was we initialize a variable, we have a condition that we check, and then we do something to the counter in the final expression. I made no references to, oh, am I always adding one? Am I always decreasing one? Am I always doing something else? And that's because a for loop is actually very agnostic. It's very there's nothing about a for loop that says, oh, we only use it by adding one to the counter. It happens to be how we most commonly use it, but it's by no means the only way, right? Because nothing I've just told you about a for loop indicates that it only works mathematically when we increment by one. And so because of that, here we have another for loop where we still have our initialization, which is I equals 5. We still have our condition, which checks to see if I is greater than or equal to 1. We have our code block, which just console logs out I. But now in our final expression, notice how we're decrementing I every time, right? We're decreasing I by 1. And if I just kind of look at this code intuitively, I see that we start at I equals 5. We're checking to see if I is greater than or equal to 1. And we make I smaller every loop, which means if I start with 5, after the first loop I have 4, after the next loop I have 3 and 2 and 1 and 0. And so, I can pretty confidently say, yeah, this code is valid because what's going to happen is I'm going to go through it. Each time I'm going to decrease I by 1, and eventually my condition is going to be false, right? Eventually I will become 0 and 0 will not be greater than or equal to 1. So at that point, my for loop will finish. Right, so very equally valid too, because once again, as long as I can step through my for loop, run every line of code, and be able to justify the conditions, like everything else, flows from that workflow. Okay, any questions on for loops? So next two slides, very simple, right? If I can add by 1, there's nothing that stops me from adding by 2 or 5 or 10 or 100, which I'm doing in this case. And then lastly, this idea here is how we iterate through like things like strings and arrays. And this will probably be the most common way in which you see the problems tonight. But just notice how here when we're talking about iterating through this string, right? Notice how what we're not doing is we're not necessarily iterating through the string per se, right? Notice how on line 4 in our for loop, the first thing we do is we create this variable called I equals 0, right? So 0 is just a number, right? It's nothing except a number. It's a 0, right? Our conditional is while I is less than letters dot length. Well, what type of value is a string's length? I guess this is the best form to kind of call on people, but essentially, if I have a string and ask you how long it is, you're going to give me back a number always, right? You're going to tell me this is 1 character long or 5 characters long or 0 characters long. Like you're going to give me back a number. And then on the final expression part, I have I plus plus, which is once again I'm adding 1 to I. And so we start off with I equals 0. I'm always comparing I to a number, and then I'm always adding 1 to I. And so just be very, very, very clear that when we do this with a for loop, I is not the letter, right? We're not iterating through the string by looking at every single letter represented by I. I is just a number. In this case, I happens to be the index or the position. And so where we actually access the letter is actually on line 5 there. Notice how on the right-hand side of the equal sign, we have the letters variable, which is a string, and then we use bracket notation, the two square brackets, and we've put in a number. In this case, we put in I there. And so that basically says, hey, for this string, give me whatever is at the ith position, right? So if I equals 0, it says, give me whatever thing you have at their 0th position, which happens to be the first letter. And as I increments by 1 every single time, what we do is we're going to go through 0. So if the letter in this case is 7 letters long, we're going to go through 0, 1, 2, 3, 4, 5, 6. And for every one of those numbers on line 5 there, we're going to say, hey, give me the character at 0 position, 1 position, 2 position, 3, 4, 5, 6. And so by doing that, we eventually get access to every single character in the string. And I cannot emphasize this enough, I does not represent the letter. It just represents a number, which in this case we happen to use as the position of the string. Once you know what position you want to access, yet you still have to do what you're doing on line 5 there and go to the string and ask for the character at that position. Okay. Any questions there?
If you were to let I equal 2 or 3, would it just start at that letter in the string and it would just skip over the A, B, C?
Yep, exactly.
For the first 3? Okay.
Yeah, if you started at 2, it would skip the A and the B.
Mm-hmm. Okay.
Yep. Cool. People are listening at least. Yeah, a lot of times when I lecture, especially when people's cameras aren't on, I feel like I'm just like talking to a wall. So it really helps if people just kind of chime in every once in a while. At least kind of gives me comfort that people are following along the slides and I'm not kind of going way off the rails where people are super confused about what's going on. Okay, so that's pretty much it for the for loop 2. We're going to talk about 2 more things here and then wrap up this section on loops. One of the things about loops that kind of makes them really really ideal is, hey, we can keep doing the same thing over and over and over and over again. But sometimes we actually want to have some control over the looping, if you will. And so we have a few tools that kind of help us make that a lot easier. So the 2 we'll talk about today are continue and let me just fast forward to the next one real quick. I want to say I don't think it's break. Okay, so we don't cover return. Okay, sorry. So make sure we don't cover return. Okay, so for the continue keyword, what the continue keyword does is the continue keyword actually basically is a way for us to run part of a loop, right? So in this case, in this for loop here, we basically have something where we start I equals 1. We're trying to make sure I is less than or equal to 5. And then after every code block, we add 1 to I, right? So I is going to go from 1 to 2 to 3 to 4 to 5 to 6, and then we'll stop at 6, okay? If we look at our code block, if you notice what the code block does is on line 7, all we're doing is printing out console logging out what is I. But on line 3 through 5, we have this if statement. And in this if statement, we have this continue keyword. And so the way to think about a continue keyword is, in our loop, as soon as we hit the continue keyword, it means we stop running the rest of this loop and we're going on to the next iteration of the loop from that point onwards. Okay, so if I hit continue on line 4, I don't run lines 5, 6, or 7. But I also don't end my for loop. I just tell the for loop, hey, move on to the next thing that you were going to do. Okay, so how this looks in real life is when I start this for loop, I'll have I equals 1, right? And then on line 3, I'll say, is 1 equal to 3 or not? And the answer is no, it's not. So we don't go into line 4, right? We go directly to line 7 and we print out I as 1. We then increment I by 1, we increment I by 1, so now I is 2, and we check, is 2 less than 5? The answer is yes, it is. So then we go through this line 3 through 5 again, we say, great, is 2 equal to 3? And the answer is no, it's not. So we skip lines 3, 4, 5, 6 again, and we go to line 7, and we print out I is 2. After that, we increment I one more time. So now I is 3. Is 3 less than 5? Yes, it is. So we go into our code block. And then on line 3, we say, is 3 equal to 3? And the answer is yes, it is. Once we hit that, we go to line 4 and we'll hit the continue keyword. At that point, what we do is we say, great. When we hit continue, it means we don't run lines 5, 6, or 7. Like, we're basically done with this iteration of the loop. And then we say, just go to the next iteration. And so what's the start of the next iteration? Well, the next iteration is, well, let's add 1 to I. So now 3 becomes 4. We then check to see is 4 less than 5? And the answer is yes, it is. So then we go back into our code block. We say, is 4 equal to 3? No, it's not. So we skip lines 4, 5, and 6. And we print out I is 4. And then subsequently, we also do the same for 5 as well. And so the point of this example is to show you that we've console logged out I is 1, I is 2, I is 4, and I is 5. And we skipped I is 3 because when I is equal to 3, we hit the continued keyword. And the continued keyword basically means nothing else is going to run for the rest of this iteration of the loop. But I want you to keep going on to the next iteration of the loop. Yes? Good? Okay. Once you use it a few times, it'll become very intuitive what it's doing. But this is just something that kind of gives us a little more degree of control over what part of the loop we want to run. And then, yeah, the continued keyword works in both while loops and also for loops, right? So here we have our continued keyword on line 7, and all we're saying is, hey, if the number is even, then don't console log out the number. So in this case, then we only console log out all the odd numbers. Right, I think it's odd numbers. I actually can't see the printout screen because Zoom blocks it on my side. But I think it's odd. Yeah. Okay. This is a contrast with the break keyword, right? So the break keyword is almost identical to the continued keyword with one very, very critical distinction. The continued keyword basically says, hey, stop running the rest of this loop, but go to the next one. What the break keyword says stop running this loop, and also don't run any future iterations. In fact, this entire loop is just done at this point, right? It's like a panic button, like an escape button, like an ejector seat. Like, it basically ends this loop at this point in time. And so here, notice how we have a while loop, and notice how on line 4 there, our conditional, it's just true. It's intentionally designed that this will be an infinite loop. It will run forever and ever and ever, unless somewhere within the loop we break it. And in fact, we do see the break point on line 8 there, right? Continue and break are both, once again, reserved words, so you can't override them. So wherever you see continue, wherever you see break, this is what they mean. There's no ambiguity there. So when you see the break keyword there on line 8, it basically says, hey, we have this variable called myGrade, which is an A, and I'm going to keep adding pluses to it. And eventually, when my A has, I guess, 2 pluses after it, I'm going to break, which means I'm going to stop running the rest of this iteration of the loop, and I'm also just done with the rest of the loop as well, right? I'm going to stop running this iteration, and I'm also not going to run any future iterations either. And so in that case, we actually just end the loop at the point where we see break. So once again, just to recap, continue basically means stop running the rest of this loop, but go to the next one. Continue means stop running the rest of this loop, but go to the next one. And break means stop at this point in the loop and don't run any more future loops either. Like, we're just completely finished with these loops. And yep, this extends to both, once again, extends to both while loops and also for loops. Cool. All right. Any questions on loops, continues, or breaks? This is going to be the meat of today's discussion and what you'll be doing throughout the majority of the workshop. The next few slides I'll go through really fast because, once again, they're on debugging, so it's more of like here's some basic principles, but really a lot of it's more on practice, when you actually write your code. But more importantly, any questions on any of the loop materials that we've covered so far today? All right, cool. I'll take that to mean everyone feels really good about loops. Okay, so debugging. Yeah, so these slides will be a lot more qualitative, right? They'll just be more kind of a combination of opinion and experience and kind of like good to knows. But don't get down when you find yourself debugging more than writing. In fact, in every coding environment, you will almost always spend more time debugging and testing than you spend writing good code. Um, so a few things about like the test suite that you'll be using. So yesterday when you did the workshop, you notice that basically everything started off as passing. When you first log in, and that was intentional by our part, right? We want to show you that hey, even when you use like poor naming or poor conventions or poor spacing, like the code will still work. It's just really ugly, but it's also really hard for other people to work on your code, right? Today, and also for basically I think all future workshops starting from this point forward, when you start working on the workshop, every test will be failing, and so your goal is to get all of them to pass. Okay. The screen on the right hand side kind of gives you a pretty good idea of kind of what that looks like. Notice how right underneath this Jasmine, you'll see a green dot and 3 X's. This basically means there are 4 tests on this page, and in this particular screen, it means you're passing one of the tests and you're failing 3 of them. The green circles and the red X's do happen sequentially along with the rest of the code on the page, which basically means if you see 4 tests in that order, that basically says you're passing the first one, but you're failing the next 3, right? Because it's green circle and then red X, red X, red X. And then we also tell you right beneath it, you have 4 specs, 3 are failing, and if you click on that, it'll actually tell you which ones are failing. Okay. If you go down the next line, it says only odds returns a number. That's going to be the name of the test that's failing. And so when you go to your workshop page and you look at the code, you'll see exactly which ones are failing, or you'll see the name of the test for the ones that are failing. And then lastly, beneath that, you'll see basically the last line as to why your test is failing. This, I cannot stress enough, is super valuable, and I think especially when you're starting off with programming, this is one of the biggest kind of time sinks for people is people, they write some code, they run the test, they fail, and they're like, oh wow, my entire code must be broken. Let me start from scratch again. When in reality, it's like, well, what's broken, right? Like if you know what's broken and you say, oh, I have a really fundamental problem, I need to rewrite everything, that's fine. But if you have a 10-step, process and only the last step is broken, why are you rewriting the first 9 steps, right? And so before you when your test fails, before you try to like erase code or write new code or fix it, please read the error logs and at least understand why something is failing, right? It's like you can't repair a car if you don't know what's broken about it, right? You can't just, if someone takes a car to your shop, you don't just start working on it right away. You kind of ask them, hey, what's the problem? And then you test it out to figure out, oh yeah, the air conditioning is broken, right? Or the steering is off or something like that. Same thing with code, right? When a test fails, it means your code isn't doing something correctly, but like what isn't it doing correctly? Like at what point are you failing? And so if we look at the example on this page, reference error is a common one when you're first starting off. That basically means you're using a variable that you haven't created yet. And in fact, if we look at the error log there, it says reference error, sum is not defined. That basically means you're trying to use this variable called sum and you haven't created it yet. So as far as JavaScript is concerned, it says, I don't know how to move forward at this point because you're trying to use something that you haven't made. If you go down, you actually see, it'll actually tell you which line of code is problematic. So if you look at the very end of that line that starts with at only odds, you notice 2 numbers separated by colons. The first number to the left of the colon is usually the line number in which your code is broken, and the second number is a character number. Character isn't really used as much. I think once you tell people which line the code is broken in, they can kind of work backwards and figure out what the problem is. But once again, these error logs kind of are our way, or the computer's way of trying to help guide you to, hey, this is a part that we think is broken. You should, rather than restarting your examination from every part of the code, you can start here and try to figure out what's going on here. Yep. So it'll tell you what line is broken, and those lines are what we call the stack trace. So the computer will kind of tell you everything it done, and all the steps it took up to the point in which it reached the error, right? And so the way that the stack trace works is the most recently line that got run is the first line, and then the line that took it to that line is the line beneath it, and the line that got to that line is beneath that. And so when you see an error, you can actually kind of say, oh, the computer tried doing this, which made it do this, which made it do this, which failed. And so now in your mind, not only do you know kind of where something happened, you also know how the computer got there. And once again, these are things that as you do more and more workshops, you'll just get a really good, hopefully you'll get a much better sense for kind of how to read these logs. And these logs sometimes they could also be misleading, right? Like, if I go back to the car analogy, someone might bring a car and be like, hey, my car's not driving correctly. I think the engine's broken, right? And maybe that's like a symptom, but maybe maybe the root problem lies in the transmission, right, or lies in somewhere else. And so just because that's where the issue was observed, it doesn't always mean that that's where the error happened. Although it's always, it's typically a very good place for you to start your investigation. And then obviously at this point in this day and age, like if you don't know what's going on, or the error seems really kind of misplaced, like Google it, right? Like almost every issue you'll encounter throughout this workshop, you won't be the first one or the only ones to encounter it, and other people will have too. And so, feel free to rely on the resources of the internet to help you along. Okay, so test failures basically fall into two buckets, really. One failure is, hey, your code is somehow miswritten, and I just cannot run it. Like the code will not run. You're using a variable you haven't created yet. You're using a incorrectly spelled keyword, etc. Like there's like something like there's something that kind of technical about it that's not working. On the other hand, the other type of failure is saying, hey, your code runs. It runs fine. You just gave me the wrong number, right? Like in this case, you'll see like the error says expected 55 to equal 25. That basically means, we expect the answer to be 25 and you gave me 55, right? Your code is not run technically. It just didn't run it. It just didn't compute the right value. And so in that stage of error, you actually want to be able to step through and try to figure out how the computer solves a problem versus kind of what you were expecting it to do. And then lastly, if you get undefined as an error, it basically means your code is not returning anything. We didn't talk about this too much today, and I think you'll touch more on this tomorrow probably. But returns are very critical because ultimately console logs kind of help you see what the computer is doing, but return is the way a computer actually passes a value back and forth. And so whenever you see that you're getting an undefined value, it basically means your function is not returning the right thing. And the way to see what a function returns is very easy. There's a return keyword, and whatever comes after it is what gets returned. So if your function doesn't have a return keyword, then by default you're returning undefined. Otherwise, you return it will return whatever you tell it to return. Yep. So then, when your tests are also failing, you can also just scroll through to the bottom of your of the sheet, and it'll actually not only will you see what the test is called, you actually see how the test is being run and how the values are being captured. So between this, so if you know what the test says and you see what the results of the test are, you should be able to kind of work your way and kind of piece together what happened when we tried running your code and why didn't it do what we expected it to do. And then this last thing, I'm actually not as big of a fan of. There's something called a debugger keyword. Basically what this does is if you use this in most editors, what it does is it will actually stop the code at that point in time, and it will give you the option of trying to figure out, what the values are at that point in time. I would say that for this workshop or this bootcamp prep class, it can be useful in certain contexts, but also can be a little bit tricky to learn and use. And so honestly, for these first few workshops, I would encourage you to just try to like reason through, use console logs, try to figure out like what your code is. Really try to understand what your code is doing. Because I've also seen folks use debugger, and it takes a bit of time to learn and get comfortable around. And I think you will probably benefit from writing more code as opposed to learning how to use debugger. Because at this point in time, all the errors that you encounter are things that you should be able to reason through and kind of figure out like what's going on at each step of your code. So I won't cover too much in debugger, but if you do want to use it, you have access to all the slides, so feel free to take a look at it. It's a little bit more of an involved process, but essentially it's just a tool that can be helpful, but you by no means have to use it for this class. Okay, cool. That took slightly longer than I wanted to. But any questions on debugging? But I guess mostly on the loops portion. Nothing? Everyone good? Okay, cool. the last thing I'll do then is I'll actually so the workshops are now available, but let me just really quickly go into this and show you a few things and hopefully make sure that you're starting off kind of on the right foot here. Your screen might look a little different from mine depending on how you have it set up, but this is basically what it is. So notice how you see this thing called describe. Everything beneath this are the tests that's going to be running, and notice how when we say you can actually see how the tests are running, like we mean you can see how the tests are actually being run. You'll basically you should not be touching anything beneath this describe keyword. This is a test, right? Like it's like taking a final exam and saying I don't know the answer, let me change the test, right? Like we really shouldn't be doing that. Nothing beneath, you should not be changing anything beneath the word describe, right? Your code goes here, and then if you go to the README, hopefully the README gives you kind of a good sense of kind of what we're asking you to do. In this case, we're asking you to define a function, only odds that does all of these things. Under specs, when I run this code, you'll notice how when I run it organically by default, I have 4 failures, which is one of these, which are these tests. And so once again, as in contrast to yesterday, when you start off now, all 4 of these tests will be failing, and the goal for you here is to get all 4 of them to pass. Cool. That's it pretty much on my side. Any last minute questions before you start work on your workshop? Very cool then. All right. I will get you broken up into rooms, and then yeah, we'll be good to go. Let me